Hello everyone, welcome to my channel. In this video, we will learn about Liskov substitution principle. So, this is another important principle of solid. So, from the word solid, the third letter is L. That L stands for LSP, means Liskov substitution principle. So, before this, we have already learned a single responsibility principle and OCP principle, that is open close principle. So OCP informs us that we need to rely on inheritance, means we need to use inheritance because it is open for extension. But then what does this Liskov substitution principle tells? So here the key word is substitution, means what type of thing we need to take care while substituting one object with another object, how the substitution will work properly. So this LSP focus on that. That means it focus or it emphasizes on the way of inheritance, what an ideal inheritance should contain or what it should be. So it's a we can say strong behavioral subtyping. So a subtype, that's the keyword. So subtypes must be substitutable for their base types. What does it mean by? It means you should be able to substitute your parent class with its derived class without any change in behavior, or we can say undesirable behavior. So this is a mathematical expression is provided it tells the same thing, that you can substitute your parent class with the derived class. So for that there are certain rules we need to follow, and we'll learn about those rules now. So let's take an example. Where in this example we will say that A is the supertype of B, or again B is the supertype of C. So flow is A, then B, then C. C is the childmost class, where A is the parentmost class, and B belongs to in between. Okay. So first we can say in case of inheritance, obviously there will be one parent class or base class, another will be child or derived class. So there are certain rules we need to follow. First rule will be signature requirement, which first category we are saying, it's not first rule, one category is signature requirement, which is required for inheritance or for subclasses or subtypes. So here you will find three keywords. One is covariant. Whenever there is word of covariant, that means a class and its subclass, means it can work together. Covariance means can coexist. We can say think about that, coexist, or we can say covariance means parent class and child class can be replaceable. That is covariant. Contravariant, child to parent, means where covariant tells downwards from base class to derived or child class, then contravariance tells child to parent class or base class. So in method there are the three things we can say. Data type of parameters, or we can say a method contains same name, means a name, and also a method contains its argument type or parameter type, and also method contains the return type. And in few of the cases we can say method also can throw exceptions. So we need to take care of these three things. One is parameter, second is return type, third is exception. So contravariance of parameter types, Means in our child class, we can use the parameter type. Means we can say we can use the parameter type either same or its parent class. Let's say in our first column, that belongs to contravariance. So there or that belongs to first column tells about properties, second column about supertype, third one about subtypes or subclasses. So if parent class contains void set data, this one void set data of type B. In our example, A is the parent class of B and C is the child class of C. So contravariance means it tells parameters should be contravariance. Means we can include either B or A as a method parameter type in our child classes while implementation. If we write set data with type C, it is invalid. Reason that is covariance. So only type A and B will be allowed as A is the parent parent class or base class of B and B is the exact class. But in most of programming language, this parent class is not allowed as a parameter type. So even in Java you will find that the third line here, that void set data A, that you cannot write like that. Only you can write void, means only you can write set data with parameter of B. That means always it will be exact or it will be same argument types. Then covariance of return type. If we are saying that return type, let's say we have created a method get data and where return type is B type, that means we can return type C, but we cannot return type A. Because covariance means we can include or the subclasses or derived class where C is the derived class of B. So here if you find the invalid subtype A get data, that is invalid, the valid will be B get data and C get data. Now similarly for exceptions, the rule for exception is no new exception. That means here also it's like a covariance, where we can say what is allowed as a exception in our subclasses or subtype. We can use the same exception or its child class exception as throw, but we cannot use its parent class. So invalid, let's say one method is performed in our parent class or base class which throws B not found exception, and here we are saying that A not found exception is the parent class of B not found exception and B not found exception is parent class of C not found exception, like we did for ABC. So invalid syntax is if we write perform throws A not found exception, but the valid syntax will be if we write perform throws B not found exception and also perform throws C not found exception. Both are allowed. That means C is compatible with this, C not found exception is compatible with B not found exception as an exception. So that means we cannot throw any new exception. So all those things whatever we learnt now, those are related to syntax. Now we learn about behavioral requirements. So rule number 1 tells invariance of subtypes must be preserved in subtype. Okay, what is invariant? So we can say or we can expect that invariant is a state or condition which stage or which exists in lifetime of the program until it is removed or garbage collected. So the invariance should remain unchanged in the implementation of subtype. preconditions cannot be strengthened in subtypes. So what is precondition? Condition means before performing some action, generally inside any method we write some conditions. After that we perform some actions. So those conditions cannot be strengthened in subtypes or in we can say subclasses. And the reverse is post condition. Post condition cannot be weakened in subtype. So post conditions are we can say verified by the assertion keyword or assert statements. So after execution of task, the state is known as post conditions. And let's take an example of sign in class. Left side I have created the base class sign in class, and right side is the derived class as OTP sign in. So generally in sign in we give username and password to verify, and there is one login in sign in we have created, and also one logout we have created inside the sign in class. Here that username and password, those are data invariant. We are saying that those information we are storing after the login happens, and it is nullified in logout. That means here we are saying the both username and password is set inside the login method, and only it is removed or nullified in logout method. So now let's go for login. Understand this login method functionality. So inside login method we have written some precondition that username and password both must not be null to perform any action. And also means what is the post condition? This login method returns a type integer, that is nothing but employee ID we are saying. So post condition is nothing but this employee ID, or this employee ID we are saying that at max it can be 0, minimum it can be 0 or positive numbers. Generally employee ID cannot be negative. So in case of invalid we are saying that it will be 0, and it is valid, then we will get one employee ID that is positive integer. And now let's go to logout functionality. In logout, the post condition tells that username and password needs to be set as null. So let's say we want to call this sign in method from outside, and let's say we will use login method. In that case, we while testing, or let's say if you want to write unit test for that, then we can say login method returns integer type, positive integer or 0. So there we can expect that minimum value will be 0, and we can write condition based on that. Similarly, let's say in our code after the means wherever this is called, there we are again storing this value as in an array. We are storing what are the login employee ID got login. So both are means as it is positive number, so it will work, because this is 0 or any number will be considered as an index. Now we have derived another class OTP sign in. There we have overridden both of the methods, that is login and logout. If we see here in OTP flow, generally in OTP we get mobile number. Let's say that is numeric, and one OTP. Let's say we are verifying with that mobile number and OTP in the OTP sign in. So in this case, if we see the condition where we have created another condition, that is username matches with number, means as we are saying that the number will be means the text whatever the user enters, that should be number in case of OTP flow. In this case we are strengthening the precondition, and it may violate. or there will be problem, because from outside, uh, if we call this OTP sign in and let's say we pass some text, then there is that will fail. Where our base class or sign in class tells that it will work with any type of text, and our OTP sign in tells that it will work only with mobile number. So this is strengthening the precondition or narrowing the precondition, and in this case there will be a bug or not, we can say inconsistent behavior. Now, so this violates the LSP. And if we see logout, generally in logout we are expecting to clear some information like username, password, to remove that. But in OTP, user cannot log out using the OTP flow. Only user can log in. And here, while overriding, we have thrown new exception. That is throw new unsupported exception. So the state inconsistent happened here. If we call this method, means let's say we have used the type as sign in, but the actual object is OTP sign in. From calling him, if we call this logout method, then we will get exception there. But that is not expected. So this also violates the LSP, because here we can say post condition doesn't match, because post condition was supposed to be username and password should be null, but here the post condition is like it will return the exception. So violation of post condition. Also, the there is another we can say data invariant. That violation also happened here, because when we are saying that username and password, those are set in login and those are nullified in logout. That means after we call logout, the data get nulled. And in some cases we may let's say we want to save some different thing or a different string text instead of username and password inside our logout. In that case, logout tells that the state, the overall state of the data or the will be something, but if we use OTP flow, OTP sign in, then the data is not preserved. So this is the violation of LSP. Then now the major thing is that if we see programmatically or both are means there is no problem with our class inheritance. So our inheritance should be based on behaviors, not on object properties. That is the right way to use or correct way to use inheritance. Because if we see our sign in class and OTP sign in class, similar object properties, but behavior is different. In sign in, user can log out, but in OTP, user cannot log out, only user can log in. So we should model our instance based on behaviors, not on object properties. Okay. How to identify LSP violations? So one is override a method of base class method to give completely new behavior that we did now. Also another symptoms is override a method of superclass by an empty method. Like sometimes we will say that we don't need this method to be implement. So we have created empty method which doesn't perform any action. So that is also violation of LSP, because it is a complete new definition or new behavior. And what is that behavior? Nothing. And if we create document which will tell that what should not be called by clients from superclass, like in our case pre, we have told that logout will be called, but in if someone calls OTP sign in, then logout, there will be exception. That means here again we need to do additional documentations. So if we say document that certain methods inherited from superclass should not be called by clients. So methods which are inherited from superclass, if it is cannot be called by the client, and then that is violation of LSP. Throws additional unchecked exception. We discussed that there will be no new exception. So if any contents throw new unchecked exception, then that is also violation of LSP. So our LSP helps us to define the inheritance, or it tells that what is the correct model for the inheritance. Thank you.